Hi everyone, we are Team Apple Pie and we are here to talk about our new product, the Smart Airfare Analyzer version 1.0. Next slide, please. This is the agenda for our presentation. We'll go through the vision, team, problem, solution, product demo, business model, competition, and launch strategy. Next page, please. Apple Pie aims to help users find in-depth economic insights in booking flights from multiple cities across multiple time periods. By analyzing airfare inflation changes in specific routes and national average, the application will empower users to identify optimal months for booking flights and discover historical cheapest routes. Next slide, please. This is our team. I'm Yiren, I'm the project manager. Nana is the technical solution, Sion is the product manager, Ash is the market and analyst, and Jingxia is the project planner. Next page, please.
So the reason we would like to develop this tool is because we found this problem. So this year, the customer prices increase very quickly. For example, a basket of goods from the market cost around $310, which was a 20% increase during the COVID. And next slide, please. And another example is the tuition. As we all know, cost of attendance for college is very, very expensive, even compared to the customer price index. Next slide, please. And so based on this, we would like to develop a tool which can help users to save money in one aspect. So we are thinking for a flight search tool. So the existing flight search surveys such as Skyscanner are practically effective enough for traveler. However, the scope of airfare analysis is limited to nominal value and the burden to search across historical data over multiple time periods and multiple cities.
So in order to realize our vision and address the problems that Jingxia mentioned, we came up with developing a Python program that incorporates three major aspects of the problem. We would like to incorporate inflation-adjusted airfare analysis, easy search and historical airfare data, and easy search across multiple cities into a single program. And eventually, we have created a smart, comprehensive airfare analysis machine for college students who like to fly oftenly, or business analysts in the airline industry, or maybe researchers who do research on airfare or airline economics or transportation economics. And Nana will do a short demonstration of our product.
Okay, so our product, like Young and Jingxia have mentioned, is to help academics and researchers and anyone who's interested in historical airfare data. So our product has 7 menu options. The first one calculates the real values of airfares compared to a baseline year. So when our user runs the program, they are first presented with the menu, as I mentioned. And asked to input the menu option they want to investigate. So the first menu option asks for an origin city. This is the city where the user wants to investigate the airfare from. So if I type Pittsburgh in here, since Pittsburgh is part of the cities that we have data on, the user does not receive any error whatsoever. The program also asks for the baseline year. If I enter anything below 1993, the user is asked to specify the year between 1993 to 2024, because that is what we currently have data for. So if I enter 1993 as my base year, it means that the comparison year is compared to 1993. So in this case, if I enter 2000, sorry, I'm comparing the airfare values in 2000 to 1993. What I mean is you get the 2000 airfare price in $1993. And so here, our program lets the user know that the airfare price, $387.56 for Pittsburgh in 2000, is $458.15 in $1993, meaning that the discount rate and the inflation rate has accounted for the time value of money, given the separation between 1993 and 2000. So the second option basically asks the user for a baseline year again. So in this case, I'm entering 1998. And in 1998, our program tells our user that the best month to travel in 1998 was October, and the worst month to travel in 1998 was February. And this comparison is made based on the inflation rate provided by the federal government. So it means that the inflation rate was relatively low in 1998 around October, but was very high in February of 1998. If our user is to input number 3 as their menu option, they are once again asked for a base year. So I'll enter 2004. And our program prints or plots, sorry, the inflation rates for all the months in the year specified. So in this case, since I specified 2004, it has plotted all the monthly inflation rates from January to December for 2004, with the average inflation rate showed in red. That's the line showed in red. For option number 4, the user is once again asked for an input year, and I will put in 2007. And the user is once again asked for a comparison year because this menu option compares 2 years. So I'll put in just a year's difference, so 2008. So the month I want analyzed is being asked. So let's say in April. If I enter April as in its full form, I'm told to specify the month in its shortened form. So I do April as APR. So what this option does, it compares the inflation rate in April for the base year that I entered or the user enters to April in the comparison year that the user enters. So in this case, the airfare inflation rate in April 2007 was 1.2 compared to 10.1 in April 2008. And so that means that the inflation rate in April 2008 was very, very high. And this makes sense because there was a recession in 2008. So for option 5, if I enter option 5, I'm asked for a baseline year, let's say 2005. And so option 5 basically lets the user know what the average annual airfare in the year they inputted was. So the average annual airfare in 2005 for all the cities in our data source, which is taken from the federal government. So let's say Pittsburgh, Philadelphia, Newark, etc. So all the cities in the US, the average annual airfare was $415. So this is a nominal value. This is $2005. If I input option 6, I'm once again told to enter a base year, let's say 2007. And option 6 returns what the maximum airfare was and what city it was from. So the maximum airfare in 2007 was $1,583.94 from Saipan, and the minimum was $94.5 in Kansas City. So that means if our user is looking at connecting flights or the city of origin from where they should start their vacation, their flights from, in 2007, it was Kansas City. And if they really had money to spend or burn, they could go to Saipan. If the user enters option 7, this time they are asked for no inputs, but then they get to view from the federal government, the US Bureau of Labor Statistics, what's the airline fares option in the consumer price index basket is from whatever year the federal government had on hand. So in this case, it was about 1984 to 2024. And as you can see, airline fares have been steadily rising. This graph shows that the index has been steadily rising compared to the baseline years of 1982 to 1984, which were 100. As you can see, it has clearly reached about 325, but there was a really short, there's a dip around 2020, probably because of COVID, when everything was shut down and there were no flights, nobody was going anywhere. So if our user is confused about what to do or needs help understanding what each menu option means, they can simply enter 8, and it provides a more detailed explanation of what each option does. To exit the program, the user simply has to enter 0, and they are done.
For the business model part, we have identified the target customer for this product as follows. The market size relating to airline is huge. For example, there are 800,000 employees in the aviation industry, 700 million domestic airline passengers, and since America has many outstanding universities, there are lots of students and researchers in academia. Next slide, please. And as mentioned before, there are other commercial airline price trackers in the market, including Google Flights, Expedia, and Skyscanner. However, we are differentiated not only because we are curated for price analysis, but also the varied functions. We have incorporated the inflation, a wider range of historical data, comparison between cities, and the analysis for indicators like the best months to travel. And they're all listed in the function menu, which is simple to use for the customers. Next slide, please. And we envision that a small application or web page tool will be a suitable form to launch the product. And considering the mass of our potential audience, digital marketing would be effective in promoting it. For example, advertising on social medias or apply SEO strategies to receive more traffic. The key drivers to keep the product moving forward would be positive customer feedback for accurate predictions. And if the value of the product is proven by the market, we could generate revenue from subscription or commercials to improve it in the future. Next slide, please. And that's all for our presentation. Thank you.